Also, as a reminder, for more Microsoft webcasts, you can visit microsoft.com/webcasts. And again, I'd like to welcome everyone to today's MSDN webcast, Windows Communication Foundation, top to bottom. Today's session is part 11 of 15, Federated Security. And now, without any further delay, I'm going to turn the floor over to today's presenter, Michelle LaRue Bustamante.
Thank you, Tracy. Welcome, everybody. This is, once again, another installment of our WCF series. So today I'll be talking about federated security, and this is a carryover or a continuation of my last webcast, which discussed just the foundations of WCF security. Again, my name is Michelle LaRue Bustamante, and I'm an architect with iDesign and a Microsoft Regional Director for San Diego. Been working with WCF for many years now and just published a book called Learning WCF. I point that out also because the code samples that I'll be presenting today and in all of the webcasts in this series are derived from the content of my book, and you can download all of the book code at thatindigogirl.com. That's my book blog, where I'll also post other information related to the book or extensions from the discussions in the book. And then I have another web blog called dasblon.net. That's where I also will post other items. So you might want to keep an eye on both of those blogs for updates and or postings related to today's and other topics. Now today what I'll be covering is the underlying claim-based support that's built into the WCF. So essentially we talked about the fundamentals of security already, but there is a tendency today to move more towards a claims-based security model, which gives us a bit more richness than the typical role-based security model. So I'm going to be talking about that specifically today. And because this is such a large topic, obviously I'll be focusing on sort of that progression and those fundamentals that you need to know to understand why would you even care about claims-based security, and what are some of the basic things you should understand about how that works. So I'll give you some progressive steps for adopting claims-based security. And we'll talk a little bit also about security token services and how that supports a claims-based or federated security model. Now, the prerequisites for today are really just that you understand how to build .NET applications and that you have a foundation in WCF, but it's also kind of important that you have a basic understanding of security concepts. What is authorization and authentication? What does it mean to do message protection? And even if you understand all of these things, I will probably warn you that if you're not familiar with what federated security is, even though I'm introducing the subject today, it is quite vast, so I'll need you to pay attention. And so the agenda will be that I'll start with just some foundations of the limitations of role-based security, the benefits of claims-based security, and then we'll get into what are security tokens and claim sets, and I'll show you how those work within WCF. Then I'll focus on how we use claims to do authentication and authorization, a model for normalizing claims, which I'll explain when I get there, and then ultimately how we would move to a federated scenario. So this will be progressive and quite fast-paced. Starting with role-based security. So essentially, if you've done any security at all in any application, you're probably familiar with a traditional role-based model. User authenticates. They're assigned either Windows groups, let's say, if they're on a domain, or the equivalent meaning roles, and or they are maybe a custom database that has usernames and roles. And the idea would be that when you authorize access to either a set of functionality, even on the UI, or even in your web services, or your other components, you would check the role of the user in order to authorize access. And that's a typical way to do security. And this is all built in to .NET, actually. So we have actually a role-based permission model whereby we can have permission demands that we place directly in our methods, for example, where we can execute a demand that says, if this user is in this role, they're allowed in. Otherwise, please throw an exception. And so if you're familiar with role-based models, then, and I did discuss this briefly in my last webcast, I showed you how to do permission demands. I kind of tied in that, WCF service authorization at the operation level to the traditional .NET framework permission demand using principal permission. So I did this in the last webcast. And that's what I'm referring to here. The problem with this model, though, is that it's really been insufficient for years and years. In fact, I can recall back in the mid-90s building custom authorization models using permissions instead of roles, because roles are too coarse. And sometimes roles need to change. Either the name of the role changes, or perhaps sometimes when you're an admin, this will work, but let's say we allow personalization of the admin role for different groups or departments, then we need to somehow modify that role and the meaning of that role. The problem with that, of course, is that now the role doesn't have the same meaning across the application, so it makes it more difficult to do a role-based permission demand, because admin does not always mean, for example, the same thing. Instead, what we really need to do is more granular permission checks. So the idea being that I need to check, do you have the permission to edit this resource, or do you have the permission to access this feature? It's not about your role. Your role maybe just grants you the permission. So permission-based authorization is not new. This has been existing for years, although admittedly it doesn't really exist as a built-in piece of functionality even in the .NET framework. You can extend the framework to achieve it by creating things like custom permissions and custom attributes, but it's not something that's built in. So the idea of mapping roles to permissions is something you would traditionally design yourself if you need that type of detailed authorization policy. Now, of course, what people try to do is avoid this level of detail and customization in favor of productivity and simplification of the application. But it's really becoming such a necessity that we're moving towards the need for something more granular like permission-based was. And that's where claims-based authorization actually comes in. And there's a lot to this. A simple way to view it might just be to say, hey, a claim is like a permission. And that's really an oversimplification, but it might help you to sort of make the stretch to what's the difference between role-based security and claims-based security. It starts with, well, instead of just giving you a role, I might give you additional claims, like what is your age, for example, if you need to be over 13 to access the operation, or what is your not only your birth date, but maybe just other features like what features are you allowed access to. So I might have a list of features listed as part of what carries with your user credentials. And so the idea would be, instead of carrying roles with your identity, you carry claims with your identity. And the claims can be anything from who are you, your user identity, any sort of roles or permissions that you're granted, and other useful information that could be useful to the application. Now, what makes claims a lot more, solid than just a classic permission-based authorization policy is that claims are actually guaranteed by an issuer. So whoever puts the claims together and says, this user has these claims, is responsible for guaranteeing that those claims can be trusted. And the way those are guaranteed are typically by performing some action like signing a token that carries those claims, so that if you trust the signature, you know that the claims are valid. That's one example. And I'm going to go through some variations of that as we go through some demonstrations. So at the end of the day, WCF is a claims-based identity model. So underneath, even though you might be using Windows credentials or username and password or certificate like I did in the last webcast, in fact, WCF converts those security tokens that are passed in a message to a set of claims. So whether it's Windows username or certificate, those are all security tokens that are used to authenticate, and they can all be mapped to a list of claims. While a Windows token might have SID claims or security identifiers from the domain, a username password might just carry the username, and a certificate might carry additional. And I'll show you that when I go through an example shortly. The point is that even though you might be used to using WCF right now, using Windows or username or certificate credentials, when you make a call from a client to service, those credentials get serialized to a security token and converted to a set of claims, even though we might not see the claims because we're actually doing traditional role-based security still in the case of username and Windows. But you can access those claims through the security context. So the service security context is that construct that is initialized for every request with information you can access about the request and the security context of the request. It includes access to the identity of the caller and the claims that were assigned from the security tokens passed. And so what happens is those are converted to a set of claims, each token. So again, a security token is what? It is a representation of a set of credentials. Usually it's a binary security token or an XML security token, meaning that it's passed as part of the SOAP envelope in the security headers with the message. It's usually signed to guarantee its authenticity. In fact, if it's not signed, you shouldn't really trust it. And so that's kind of built into WCF. When you send a security token, it is signed with the signature for the message usually. And then we've got encryption to protect the details of the security token during transit so that they can't be viewed by malicious parties until it reaches the destination, which is the application they're being sent to. So the idea is that any time I authenticate with Windows username or certificate, let's say, to use familiar terms, those will serialize into some form of security token into the message and then be processed at the WCF service. This is all handled by the plumbing underneath. Of course, as far as you're concerned, you attached the username and password to the proxy and it got serialized for you. And as far as you're concerned, when the operation is called, authentication has already happened against whatever the membership provider is, like I talked about in the last webcast. So a security token can be any type of credential and is converted to a set of claims, and those claims usually always have one identity claim, which could be representative of a Windows account or an X509 identity or a username. And then a proof of possession claim, one or more of those will exist that indicate other details about the token, like what did the token have in it? What claims did it provide? Maybe just the username, or maybe it was, in the case of X509, a number of details about the certificate, including the subject key. Regardless, whatever the token provided, the set of claims that it evaluates to are authenticated or authorized by a particular issuer. And so the issuer itself has to be identified as well in order for the service to trust those claims. It needs to know, hey, did this come from a trusted issuer? Do I trust that issuer? And the issuer can be just the system, meaning for a Windows machine, if I'm using NTLM, it could just be the system issues a set of claims for me after they authenticate the token. With X509, it can also be a system issuer, or it could be a actual other certificate. So like the certificate authority would be an issuer. With username password, the ASP.NET issuer is used, or the membership provider. With CardSpace, it's actually a certificate that's used to sign the token. So the point is that there is some logic here that it's not just that I received a token that turned into a set of claims that said what my email address was and what my username was and so on. It's that the issuer was also trusted, therefore WCF will allow me to use those claims. And you can actually get involved in the authorization of the issuer as well. So what happens is, again, just to simplify, you pass a Windows credential, a username token, a certificate. That gets serialized to a security token in the message. The service model, meaning the WCF plumbing, will actually generate the claims from the token for you before you even get the operation call. And that's based on your configuration, which I'm going to go through. What happens is, for every single token that is received, WCF has a security token authenticator type responsible for handling the authentication of the token and converting it into claims. So just to show you a list, even though we won't go through each of these in detail, there's a Windows security token authenticator for NTLM, then there's Kerberos. There's X509 token authenticator. There's a Windows username token authenticator, meaning I pass the Windows credential in a username token. We've got a custom username security token authenticator for when I pass a username and password for custom membership provider, for example. And then we've got a SAML security token authenticator when we receive an actual XML SAML token, which I'll talk about a little bit later. The point is that there's an object that's responsible for reading the token out of the message and building a claim set. And you'll see that there's a Windows claim set or an X509 claim set or a username claim set, for example, that can be generated based on the type of token passed. So with that, let me actually help you to visualize this by going through an example. So I'm going to share my desktop, and what we'll do is go to one of the samples I have here called Security Token Claim. And what this does is the following. So let's start by looking at the service. I've got a Windows authentication service. In fact, I have a base service that has a single function called authenticate. And in that function, authenticate, what I've got is some code that's going to look at the security context, check to see if it's filled in or not, meaning I'm not anonymous, and it's going to go ahead and print to the console the security context primary identity. It's going to print to the console information about the authorization context inside the security context. So what we're used to doing when we call a service operation is possibly doing some sort of permission demand up here using a principal permission attribute, for example. And what I'm going to be doing in here is just showing you, besides looking at the current thread security principal, I can actually use the service security context to get at the primary identity and also more information inside the authorization context, which includes all the claims. And so, in fact, I can iterate through the claim set of the authorization context. And for each of the claim sets I receive, I can actually print out the details. So I'm going to throw a breakpoint in here just so you can see at least the first time through. And we'll go ahead and run the client. So basically what's happened here is we've made a call. I've printed already the primary identity to the console. So the primary identity, as you can see with my IntelliSense here, is Michelle. So I'm logged in as Michelle. Therefore, that was used to log in using NTLM. So that's my primary identity, which, by the way, is the same thing as the security principal attached to the thread, which I talked about last webcast. Now, what I'm going to do here is I'm going to look at all the claim sets that were created, and there's only one in this case. And what I'm going to do is print to the console that claim set. So what you're seeing here is an extension function that's using .NET 3.5, which is going to take the claim set I pass in and basically write information about that claim set. Now, the things I'm going to write are the following. There is inside a claim, a particular claim, a resource, which is the thing I'm protecting, the actual claim type, and the right. Now, before I spend more time here, actually it's going to time out. So what I'm going to do is get rid of the breakpoint and just let all this dump. I just wanted to give you an idea that I'm getting all this information actually out of the service security context. So I'm going to get rid of my breakpoints and just let it run. And what you'll see here is that my primary identity, I must have used a Windows credential. It's a Windows identity. The claim set type that was generated is a Windows claim set. The claims are a bunch of SIDs. There's an identity claim, which is an SID, which would be my account. And then there's a bunch of possessed property claims, which is just additional information. One of those is a name claim, which says my name is Michelle, or my username. And then the rest are all SIDs, which are the security identifiers generated based on the fact that I'm authenticated by the Windows domain, which is really NTLM in this case. The issuer of those claims is self-issued, and it is another SID, which is actually the NT authority on this machine. So that's S-1.5. The point is that I sent a Windows credential I received a Windows identity out of that whereby I can do role-based security, so that's normally what I'll do. But I actually do have a Windows claim set, although, as you can see, it's not all that useful to me unless I want to go and convert all those SIDs to something meaningful to get all the group information and so forth. The issuer was the NC authority, which is the machine. Now let's take a look at another example where I will pass a username. And in this case, what's happened is I've received a generic identity, not a Windows identity. The name is admin. The authentication type is the membership provider. The type of claim set generated is the username claim set. The claims that were passed is just the name. The identity and possessed property are a name claim saying my username is admin. And the issuer is the system, which basically just means, look, the code was executed within the WCF system, which is the underlying built-in WCF code for authenticating that token and converting it to claim. Now, to continue, I'm going to send a certificate now. And what we get here is an X509 identity. The name of it is the subject key. Subject key is the name of my cert that I used to authenticate. It's an X509 certificate claim set, and if we open that up, you can see that there is a subject key. The DNS is subject key. The name of the cert is subject key. Again, that's the name of my cert. We're not going to open up the byte array of the thumbprint and so forth, but it will match my subject key, which is a certificate installed here, by the way, in my current user personal store, subject key. And all the details of that cert, in fact, including the issuer, which is a self-issued. So in other words, subject key, the cert, was issued by itself, which is also subject key. And you take a look in here and you'll see the thumbprint. So those are all of the details, again, that I'm getting in the form of claims, the distinguished name, the thumbprint, and so forth. And that kind of makes sense, doesn't it? Now, out of all of these examples so far, Windows and username, we typically do role-based security against. So looking at the claims is less useful. But with certificates, you could see maybe there could be some use in checking the claims themselves to compare thumbprints, maybe to look at the thumbprint and look it up in a custom database where I've mapped the thumbprint to a set of rights. That kind of thing could be useful. Now let's continue, and I'll show you one more example where I'm going to send a card space credential, which really is allowing me to, I'm going to select a card, which is really going to generate from my machine a SAML token, which is an XML token that has one job to do, really, in this case, and that is to send claims. And the claims that are going to be sent are my email address, my date of birth, and that's actually not my date of birth, but that's okay. And so now, if we take a look at what was dumped out, you'll see that I got a generic identity, but it's not authenticated. Why? Because I didn't write any code to look at the SAML token and the claims that were passed and look that user up against some custom data store. There is no way to automatically authenticate a SAML token because you would need to look it up against your application store in some way. So all we know is that it's a valid token, but we don't know yet that we identified the subject of the token. I'd have to write some code to do that. But I still get access to the claims. And the claims are actually, there's actually, I should say, two sets of claims that were passed. The first is a key, which is an RSA crypto service provider shown here. But basically what's happened is the token was signed with a private key from CardSpace. And that private key was self-issued. And then the second set of claims that were passed is the actual card, the actual claims associated with the card, which is my email address and date of birth in this case. Those are two possessed property claims. Notice there isn't an identity claim, which is part of the reason why we don't have an identity that has been authenticated. And the issuer of that is the same RSA crypto provider as the previous set of claims. So what that tells you is that when I sent the CardSpace card, 2 tokens were evaluated into 2 separate claim sets. The RSA crypto provider, meaning the key that signs the actual claims, and then the actual claims themselves. So what's the point of all of those examples? Well, essentially what you've seen is that using the authorization context, I can get access to the set of claims for any token, even though with username and Windows, it doesn't necessarily make sense that I'd write a bunch of code like that. So let's continue and discuss that a little bit further. So the service security context, like I mentioned, is available through the operation context, and it's initialized for every call. It gives you access to the primary identity, which is what I was showing you. And the Windows identity property is only initialized if we send a Windows credential. I talked about this a little bit also in the last webcast. What we're really introducing in this webcast is the authorization context and the idea that, hey, even though I have a primary identity and I have a security principal potentially attached to the thread, if I'm using anything other than username and Windows, I might need access to the claims inside the authorization context to do something more interesting. And in fact, since every token turns into a set of claims, I have access to that. Now the idea is that, again, a security principal is attached to the request thread for any authorized caller, although it may not be authenticated, as you saw in the last example with CardSpace. That security principal is an iPrincipal type. And that security principal for a Windows credential is a Windows principal. For a username password that is authorized against the membership provider, as you saw last webcast, is a role provider principal. In either case, the main functionality of that iPrincipal object is in role, which implies role-based security. So there is no way to say, do you have this claim? The only thing we can do with the iPrincipal is say, do you have this role? So if we want to do something more interesting, then we need to go to the claims in the authorization context. So we can inspect the claims either manually in each operation, writing code to look at the authorization context, or we can create a custom authorization policy and more globally view each of the claims that were passed and do something interesting with that. Or we can build some sort of declarative model, which I'll show you at the end of this webcast, that will allow you to inspect the claims but not litter your code with a bunch of details. So let's sort of go through a progressive analysis of the things we can do. One of the things we might do in an operation, if we wanted to look at the claims, is we'd look at the authorization context, iterate through the claim sets provided, and obviously, since more than one claim set might exist, if I'm doing authorization, I probably care about a particular claim set. Like, for example, I might be looking for a type of claim set, like X509. And then after that, I might check that it contains the correct DNS claims, like subject key might be the only key I trust. Now, fortunately, we actually don't have to write this code to make sure that only trusted callers that provide certificate get in. We can also just use the trusted people store and put the public key in there, like I showed you in the last webcast. However, this just illustrates that if I had interesting claims, which we'll get to, iterating through the claim sets looking for the right claims could be useful. Of course, with Windows credentials, you could do the same, but this isn't all that useful because what do I care about the Windows claim set and all the SIDs? I would have to actually most likely rely on role-based security in the case of Windows credentials. So although you can do this, again, it doesn't look all that useful till we get to something more interesting. So that's where we get to talk about why would we bother with claims-based authorization. If it's not useful with Windows credentials or username credentials, and in fact with certificates I can do authorization using the Trusted People Store, why do I care? And the main thing that we care about, first of all, is useful when you have tokens like SAML tokens in the CardSpace example that carry nothing but claims. So what we're doing is we're cutting to the chase, and instead of having to look at a Windows credential and map it to a set of permissions or claims, doing that in our code, we might receive a token that already has all those claims inside, and that might be carried in a SAML token. One of the main reasons we might do this is because what we'd like to do is have a service that instead of supporting multiple endpoints for username and Windows and certificate authentication, what we do is we map those credentials, once authenticated, to a normalized set of claims that define the rights I have in the application so that my service developers can focus on just what rights do you need to have, what claims do you need to call this operation. I don't care how you got the claims. I don't care if they map to your Windows group or your username password role or your certificate to a set of claims. I don't care how you got the claims. But as long as the correct claims are attached to the security context, I can do authorization at the operation level. And that normalization is extremely powerful in today's day and age where we sometimes have to build services that support different types of credentials. It saves the rework or double work of having to authenticate in different ways. It allows us to centralize that to another location. It also allows us to delegate that to another service called a security token service, which I'll show you as well. So the idea is that we get to have rich application claims at some point that allow us to authorize access to specific operations. Do you have the right to create a customer or delete a customer? Do you have the right to create an order or delete an order? So if you think of a claim as a right to act on a resource, then the claim type being create and the resource being customer, or the claim type being create and the resource being order, kind of makes sense. Claims have that combination of rights and resources. So the idea, again, is that we want to centralize how we do authorization. And one way to look at it is I might have a client that authenticates against the Active Directory store, and this is an intranet client, and then I might have external callers that use a Windows username and password against the custom SQL store, and then I might actually also support certificates for some of our partners, and that's how they identify themselves. And then I may also use card space, for example, or even just have a token issuer issue a SAML token. In both cases, it's a SAML token that provides claims, so we go and validate against the claims that we need for the operation. Imagine having to have a set of services, or even a single service that supports one or more sets of authorization or types of authorization models. If we want to normalize that to make it so that the service developer doesn't have to write different types of code to authorize against the Windows domain groups and as well the custom groups or roles, for example, then we can set it up so that the service developer only cares about claims. And then somebody else can worry about mapping each of those different credentials. And so every security token provided will then be mapped to a set of common application claims that allow you to access certain features, for example. And then somehow we make sure that that is the set of claims that gets attached to the security context. One way to do that, without moving to a completely delegated model, a way to introduce claims-based security to your applications today is to do the following. Allow your services to expose these 4 endpoints for different types of credentials. However, in the service code, you only care about claims. So you're going to expect a custom authorization policy to intercept each of the different credentials that could come in and map those to a unified set of claims that get passed in a SAML token. And that means that, set of developers up here is worrying about, hey, how do I map the different credential stores to the right sets of application claims? And then my service developers down here just say, hey, I'm going to assume I got a set of claims that I trust, and I'm going to write code to validate against that. Now, the way to do that is to create a custom authorization policy. And so how we do that is, first of all, you implement an I-authorization policy interface, and you specify the type that you created in a service behavior. The service behavior has a service authorization section, and the policy, this authorization policy section allows you to add one or more, and they'll be invoked in the order they appear. And so what you do is you add your claims authorization policy, let's say, and then that will execute your authorization policy, and your job would be to take whatever credentials were provided and map them to a set of claims and put those in the security context. Now, principal permission mode actually refers to whether or not we generate an identity for the security principal that gets attached to the thread. If you leave this as the default, it'll try to do a Windows principal. If we set it to membership provider, then it will try to do a generic principal or a role provider principal. And if we put custom, then we have to write the code inside the claims authorization policy to create our own type of principal. And I'll show you that in a second example. Now, how do I implement I-authorization policy? It's actually just an evaluate method. That's the main thing that we implement. And then there's an issuer. So who is the issuer of the claim from this policy? You can decide who the issuer is. It could be that you use a key or you use a named claim. So I'll show you an example of that. The main thing, though, is the function evaluate, which passes in an evaluation context that looks like the authorization context, and it gives you access to whatever identities are present and whatever claim sets are present that you can then evaluate, and or you can add new claim sets. So I'm going to actually go through this with you in a demo. I think that will make things a little easier to follow. So let me just go over to an example that doesn't have one yet. And we'll just show you from the beginning, how do I create this thing called an authorization context? So I'm back at that same Windows service we were looking at before, the Authenticate service, that dumps out all the security context information. And what I'm going to do there is add a new class. And that class is going to be custom authorization policy. And we're going to implement I-authorization policy. And this will require me to add the identity model.policy. We'll implement it, and you'll see this evaluate method was provided. Now, instead of throwing an exception, which won't be incredibly useful, I will do some work, and that work will be to, first of all, get the identities that have been created. So remember, there's a security there's already been a number of security tokens, or at least one, that has been authenticated, and the claims have been attached to the evaluation context for evaluation, but in addition, any identity claims have been created already. So I can actually get the identity. So I'm going to go ahead and do that. Evaluation context dot properties. And what I want is the identity. And so this is going to give me a list of identities. Now, I can loop through each of those identities. What I'm going to do is actually for each identity in identities. And what we'll do is I'll write to the console identity dot name. just going to put a heading up here so we can see that this is it. And that's it. So my goal here is really just to show you that I can get at the identities, and if I can get at the identity, then I can also decide what claims should I grant that identity. We've already authenticated the identity, but we need to authorize it. I'll show you the actual mapping to claims in a separate example, but let's just see how we configure this thing so that the code actually executes, and then we'll go to a finished work. So the host is where we configure this. And what I'm going to do is go to the service behavior for the Windows credential. And what we'll do is configure the service authorization policy. And what we're going to do is add the policy type, which is WCF service library dot customs authorization policy, comma, WCF service library. So what I'm saying here is I would like you to include this authorization policy when you are authorizing calls. Now, in terms of other aspects of service authorization, like service credentials, we're actually going to be receiving Windows credentials here, and the default behavior for that is to go against the Windows domain. So we're going to leave that default, obviously. So I'll get rid of that. Okay. So that is the section that we needed to add to execute the authorization policy. So now what I've got is a custom authorization policy that will be executed for the Windows endpoint. So let's go to the client. And what you'll see is that the first example is to send a Windows credential. Oh, forgot one thing. Yeah, my job in here is that if I do the work, I return true. But if for some reason I couldn't evaluate the identity and get the job done, then I would return false. I'm not going to check all those things here for time, but I have a finished example that does that properly. So the Windows credential gets sent through, and I've reached my breakpoint in evaluate. We get our identity collections, and essentially the first name is Michelle, and that's going to be the only one that we get. So if we look at the dumped out results, we have identities, MLB or Michelle at the top here. Now, that doesn't really show you the value of doing an authorization policy, so let's look at an example that actually finishes the job. So what I'm going to do is go to this simple authorization policy example where we have a claims authorization policy. And in this claims authorization policy, I have defined my own set of claims that I care about. The resource is application, because I'm not making a distinction between feature A and feature B in this small example, but I could have different resources I protect. Then I've got these types of claims, create, read, update, delete. I'm making this a CRUD service. And notice I'm using a URI to define my claim type because that's consistent with what we do in other aspects of federated or claims-based identity. So I'm being consistent with the standard. The issuer of the claims that I'm going to grant, so I'm going to actually receive a username password at the service, and I'm going to map the username password to a set of claims, and the issuer of those claims is my application. So I'm giving my issuer a name with a URI. And I'm going to generate a name claim that I'm going to use when I create a claim set, and you'll see that. Otherwise, we've got evaluate, which is what I just created, where I'm going to check the identity and do a mapping of claims. So I'm going to leave that breakpoint in there so you can see what happens. The CRUD service ultimately is going to check the authorization context, look for the claims that match that Indigo Girl issuer, and if I find the claims I'm looking for, then I'm going to check that you have the correct claim to get into this function, which is the create claim, for example. So we'll see that breakpoint get hit as well. So using administrative credentials, I'm going to hit enter here and call the service. We'll hit a first breakpoint. And what's happening is our evaluation, our custom authorization policy is being hit. And what it's going to do is check the identity, which is admin, and go and map that to a set of claims. How do I do that? Well, what I'm going to do is check the identity against the ASP.NET database using isUserEnroll. And if I see that you're an administrator, I'm going to create a new claim for every claim that you can possibly have because you're an administrator. So I'm going to give you a create claim, a delete claim, a read claim, and an update claim. These are all possessed property claims because I can't create the identity claim. And I'm going to generate a new claim set with this issuer, which is basically that Indigo Girl URI that I showed you before, the name claim, and then the list of claims get attached. So I now have a claim set that I've created. And I'm going to add that claim set, by the way, to the evaluation context. And then that claim set is going to exist in the security context. So that's job number one. Job number two is, since we can't do role-based security, then rather than have the default behavior, which would have been to try to create a membership provider role, so basically it would have been a role provider principal with a bunch of roles in it. We don't want to do role-based security, so I'm going to create a new generic principal with the identity but no role. And I'm going to assign that to the principal property of the evaluation context. Now, I have to do something here. I have to provide a principal here because, if you recall, I mentioned that if you configure, and let me just scroll to that section, if you configure the service authorization to use custom principal permission mode instead of what we were usually using, the default being Windows groups and use ASP.NET roles, then what that will expect is that I am providing a security principal to attach to the thread. I have to provide that, even if we're not going to do role-based security. Now, this is probably going to time out at some point here, but I'm in the create something call now, and as you can see, if I step through, I will be able to get the claim set. It's going to time out, so let me just run through that a bit faster. So I'm back in executing the first call to create. We hit the evaluation context. We generate a set of claims. We provide a principal without any roles because we're not going to do role-based security. And now I'm in the create something call. We're going to iterate through the claim sets in the authorization context and see if we can find the issuer that I have. So what I have to do is create the same name claim and look to see if I can find it. And if I can, then I found the correct claim set, and away we go. Now I can check to see if I can find the create claim. Notice I'm actually expanding, in this case, the same URI as we had defined as some statics here in the authorization policy. So that would be a really good reason why we create these statics, is so that we don't have to be susceptible to errors typing these URIs. And then if I find the create claim, then we're happy, we get in. Now, of course, administrator is going to get into all. So let me go ahead and restart. And we'll see what happens when it fails. So I'm going to go back to admin, execute the function again, get rid of my breakpoints, and you'll see that all the functions were called. So create, read, update, delete. Now when I'm a user, I'm only going to get the read and create claim, but we're not going to be allowed, so therefore I'm throwing an exception here, to delete something. So we get a problem because we don't have the delete claim. And that would be a way to do claims-based security. The main thrust of this demonstration, however, is to say this. I could configure this service to use one or more authorization policies. This particular one, in Evaluate, expects that you've passed a username and password against the ASP.NET Provider model to map the claims. But certainly I could add other authorization policies for different credential types, and at the end of the day, all of them would add to the evaluation context a set of claims appropriate for that caller. And then my service code doesn't care about who, if it was a Windows credential or whatnot. What we care about is all this stuff. I want to check for the right claim set, and I want to see that you have the right claim. Now obviously this is quite verbose, and we need to look at a way to simplify that so that you don't write so much code in every single operation. And we'll get to a demonstration briefly of that at the end here. Now, that illustration basically took you through how do I actually create a set of normalized claims for a caller that's provided a different type of credential. So again, that same code can be mimicked for username, for Windows, for certificate, for a different SAML token. Any token that comes in, we could look at it and decide what are the application claims you get. And notice we're doing that behind the application. So we're not sending out to another service to say, hey, generate me another token. We're not even generating another token here. We're just directly adding a new set of claims to the authorization context. And that's an easy way to sort of migrate toward a claims-based model, because what you've allowed your developers to do now is write code in the service that just cares about claims, but that doesn't care how you got the claims. It just cares who the issuer was, and it just cares that the claims are the correct application claims to get into the operation. We can decouple this work in a progressive way and delegate the actual authentication step of the Windows and username and certificate and other credentials to a security token service. And this will give you more flexibility, because instead of you having authorization policies that add burden to the web server, you might even have a separate set of security servers that manage authentication, issue tokens, and that's their job. And so we could do the same idea, only delegate it to a security token service, which is also called an identity provider or a token issuer. It implements a standard called WS Trust, which is interoperable. So in fact, we don't even have to use a Microsoft token issuer. We can use a completely pre-built token issuer for any platform that implements the correct WS Trust endpoint. The idea of the security token service or token issuer is to generate a token, which is usually a SAML token, but doesn't have to be, that is signed by them. And if you trust the signature, then you trust the sender of the token, then you trust the claims inside the token. The model looks something like this. We would delegate and actually have the security token service support all these different credentials here. And their job would be to go against the correct store to authenticate the caller and generate the correct claims, and then build a SAML token that then gets sent by the proxy to each of the services that rely on that security token service. Now the way we do this in WCF is we create a WS Federation HTTP binding endpoint. And what this does is it supports issued tokens from a security token service. Your job is to say what is the type of credential you want, and you're going to say you want an issued token. If you're using federated, that's implied. The token format must be specified, so usually you're going to use SAML, but it's not required. You could say I want a SAML 1.1 token. SAML 2.0 even that exists, but not built in the current version of the platform. And then we've got the ability to specify what claims you require and the trusted token issuer for the token. Now, a SAML token's job is to carry claims. So, in fact, you've sidestepped the whole idea of processing the token and converting it to claims. You just get a SAML token that already has the claims, and that's one possibility. The idea being that if the service trusts the issuer, a token arrives that's signed by a trusted issuer, and the claim set is automatically attached to the authentication context for you. So you wouldn't need to create a new set of claims or map those claims. You just demand a set of claims from the correct issuer. So let's take a look at federation bindings, and I'll show you how that looks. And basically, this is a finished example because for time, obviously, to go through all the steps is quite difficult in 1 hour. But basically what you've got is a CRUD service, like we talked about before, that's going to have these operations. And inside the implementation of this, we want to validate a set of claims for create, read, update, delete, like I did in the last example. Now, the service is actually going to expose endpoints. So let me shut down some of these things here. We're going to have an endpoint that uses WS Federation HTTP binding. And in that binding, we have a couple of things we need to do. We need to provide a token type, and that's provided by a URI. So this is the URI for SAML 1.1. Then we indicate the claim requirements that we have. Now in this example, I'm basically saying, look, I'm not expecting you to pass me create, read, update, delete for everybody, so they're not all required claims. They're optional claims, let's say. Let's say I require that you say that you can always create or read, but you can't, for example, update and delete all the time. So you can see that I can modify what these guys say. I've obviously been editing this, just playing around, but I'll leave them as they are just so that the demo runs. The point being that you set up a list of claim types that you require and support. You also set up the address of the issuer. So this is an address to a separate service that implements WS Trust. That's all it has to do, implement WS Trust. And then you indicate what the binding requirements are of that service. Now that can also be negotiated through metadata exchange, but I'm not going to get into that in this particular discussion. So in this case, I'm actually specifying what is the binding of the service, the security token service, what is the certificate so that we know we trust that service, identity provider key. And then lastly, one of the things that we need to do is provide known certificates. So we're not going to allow untrusted RSA issuers. We only allow SAML tokens to be processed if they are signed with one of these known certificates. So I'm saying I only trust tokens signed with IP key. And if they're not signed with that key, they don't get in. So in fact, I already know I can trust whatever claims have been added to the security context. And then, of course, I have my service certificate, which is relying party key. Now, what's going to happen when we generate a proxy for this type of binding is it's going to generate a federation binding at the client as well that lists the same claims and so forth. But I just want to point out that it is possible to do metadata exchange to discover the required claims and such things at runtime as well. I'm just going to show you one example that is actually coding in what is the issuer address and what is the binding for the issuer ahead of time so the proxy is pre-initialized with all that information. There's a lot of flexibility, though, in how this can operate. And so what I'm going to do from the client is really the same thing as we did last time, except this time it's going to delegate issuing the security token to the security token service. So I'm going to hit enter. My proxy will make a call thinking that it's going to the service, but it's going to actually make a call to the security token service first. And one of the main things that we do in here is take the claims that were assigned using the security token context, the custom authorization policy. So what you'll see here is that I've got a security token service here, token issuer, but that security token service, what it does is it maps the username and password to a set of claims, and we check that authorization context and build those claims into, I'm going to just scroll down a little bit further. So I'm basically building a new default claim set here. So I'm going to throw a breakpoint in there. And what's going to happen is we're building a SAML token with a SAML subject, a SAML attribute, a SAML statement that includes a list of attributes for every claim. So basically what we're doing is we're getting for every claim in the security context that's already been assigned for that username and password, we're going to put it into a SAML attribute. Now, my point here is not to, confuse you with all the details of SAML assertions and what goes into a SAML assertion and how do I build a SAML assertion, because that in itself could be just one webcast. How do I build a SAML assertion? But what I want you to take out of that is that you actually shouldn't even be looking at this code right here. This is the token issuer. It should be a black box to you, and all you should care about is that it implements WS Trust. And if it implements WS Trust, and it knows how to map username, password to some set of claims that you configure, then that's all you should care about, is that you get the correct token generated. Now this is going to time out, so I'm going to treat that like a black box next time and basically get rid of that breakpoint so that all we focus on is that I received claims at the service issued by a different service, the security token service. So we'll get rid of this breakpoint and that one. And what's happening now is you'll see I'm in a piece of code that is going to validate that you're allowed to call create. So I already have the claim inside the security context, but what you're seeing here is that instead of using all that code that I used last time, I wrapped up the functionality of validating the claims into a claims principal permissions type. So a custom type that I've created that is responsible, so it implements iPermission, that is responsible for, when a demand is invoked, getting the security principal attached to the thread and checking the claim. All the code you saw for checking claims is basically wrapped in this function. And so instead of all that messy code, we can do a real permission demand like we would have with other types of credentials like Windows and username using role-based security. So we're doing a permission demand. Now I'm going to time out again, but let me run that one more time. And what you'll see is, again, the permission demand will succeed in this case. And when we call for a user, instead of admin, we're going to get less claims in our SAML token, and we're going to get access denied at some point. Access denied happens inside the demand when we call check claims. So all that code wrapped into some neat little utilities. Now what you might be thinking is, well, how did we get this custom claims principal permission attached to the thread? And that was done in the claims authorization policy. So basically, just looking for the line of code that does the work, creates a claims principal when we do the map claims. And that claims principal not only holds the identity of the caller, the original identity, but also the claim set that we created. And that just makes it easy to know which claim set are we doing our validation against, instead of having to scour the authorization context for which claim set we care about. So it's all wrapped up into a nice little set of utilities. Now another way to do this, though, is to comment out that code and use an attribute. And that attribute just wraps up the claims principal permission, just like you're used to using with role-based security, using the principal permission attribute. I just created a claims principal permission attribute. And that claims principal permission attribute actually has it's extending code access security attributes, and it's got the usual functionality, basically create permission, and within it, of course, it's used for permission demands. So this will actually function identically to the last example I ran, only instead of littering the code in the operation, we're using attributes like we're used to, with a bit more of an elegant approach. And then declaratively, developers know who's allowed in. Now that in itself might still look kind of messy. So yet another way to simplify this would be to create some custom attributes that are called create claim, delete claim, update claim, and then that way you don't even have to worry about all of this junk, which is, hey, which claim type do we want, which resource are we protecting, and so on. But you get the idea that checking claims, the internals of doing so, again, access denied, what we want is to somehow wrap up all that functionality that I showed you, where we go through the authorization context, check the normalized claims that were issued, and actually make it easier to follow in code. So to reiterate what happened here, essentially what happened is the user or the client application actually made a call to the security token service first to issue a security token, and then called the operation where authentication and authorization of claims happened, and then we got our response. Now, what you're seeing up here is that we could actually add some dynamicness, if that's a word, to this with get metadata, return the policy of metadata using metadata exchange, and then get the metadata of the security token service, get that policy, and then present a UI to the user that says, hey, I need your credentials. The security token service needs a username and password. Please enter. User supplies credentials, or we do it programmatically. Then we call the security token service, issue the token, get the token back, call the operation, get a response. So all that metadata exchange part is the part that we didn't do but is possible. And that is actually really important because sometimes you don't know what the policy of security token service might be, or it may change, and you need to be able to prompt the user for that information, possibly. Another way to look at this, too, is when the security token service issues a token, guess what? That token may not include all those claims. Why do I need the token to include my create, read, update, delete claim? I may actually want to keep that behind the firewall, so to speak. And so what I really want is some sort of universal identifier for the user that has meaning in my resource STS. So what will happen is the security token comes back, just identifies me maybe with a GUID or some sort of unique username that's independent of Windows and username, password, ASP.NET, certificates, so on. We call the operation with a SAML token, but it only has a few claims, including the UPN, or the universal identifier. And then, in order to authorize access to the operation, what actually happens is the token is used to call the STS again to say, hey, in the context of this operation, let's say create, what is this user allowed to do? And then get me my application claims, and then we decide if you're authorized and give you a response. So what that talks about is really the idea that we can extend this further to having two sets of security token services or token issuers, one for a unique identifier that traverses Windows, username, etc., and another two behind the scenes during a workflow, checking business rules, checking authentication rules within those business rules, actually make subsequent calls to the security token service again and again to say, hey, I know who the user is, this is their token, tell me what they're allowed to do right now. So it's a very rich and detailed model, clearly a lot of detail. We can do a whole series just on federated security. In fact, that would be an interesting thing to mention if you're interested in that. I talked about claims-based validation using attributes briefly, but I want to point out that I know that this is not a lot of time to discuss it. I did write 2 articles for the server side, which you can find if you go to the iDesign site and look at my list of articles. You'll get the most recent articles, and that'll show you directly where to go for that information. And it walks you through in more detail a lot of the things that I just did today as well, beyond even what I did in the book. So just to sort of sum this up, claims-based security, really just to educate you on that in this webcast, is about the fact that any security token is already mapped to claims in WCF. But we don't care about that in terms of Windows and username, but we should care about that in terms of creating normalized claims where we can centralize authorization in a consistent way regardless of how we authenticated the user. We can do that with an authorization policy in an easy way just to get started and move towards that model. You could implement my declarative security model for claims-based security as part of that in order to migrate, and then later delegate to security token services when you're ready using federation binding. The federation model also supports single sign-on and claims authorization. You can actually move this to a true federated model if you're using a implementation of a security token service like the next version of ADFS will be, and like Ping Trust has today. So something that will actually allow you to chain the security token services so that a user that's identified in company A can actually call services in company B and be translated to a meaningful user or set of claims for company B. And that's a much bigger topic. So anyways, just to remind you that the code samples are on the blog at thatindigogirl.com. I do talk about this to some extent. I mean, certainly security is the longest chapter in my book. I do end with discussion of federated security as well as card space. But again, those 2 articles on the server side are great follow-on resources, so I recommend you go to that. Now, I'm going to look at questions now. I realize that this is a really tight webcast, so I didn't want to answer them throughout. But I'll take a look at those now, and I'll send it back to Tracy. So thanks very much for attending today.
Great, and I do want to remind everybody that for more information you can print the PDF of today's session, and to do that just go to the File menu in your upper navigation bar. Now is a good time to submit your questions into the Q&A panel. You just want to type them in and hit the Ask button. Also, I'm going to be posting a survey here in just a minute. If you would all please take a moment to fill it out before you log off. We really do appreciate your feedback. Now for upcoming and previously recorded webcasts, you want to visit microsoft.com/webcast. You can go here to access this webcast, which will be available for download in about 24 hours. If you have any webcast content ideas, something out there you want to see and haven't yet, we'd love to hear from you. Just take note of this link here. And here's the survey from our session today. Please follow the links provided to complete today's webcast evaluation. And Michelle, do you have any questions waiting there for you?
I have a few, yes. Okay, so one of the questions is, will some of the custom code I wrote be in WCF 2.0? In terms of my claims-based declarative model, not that I know of today. I don't see any of that in there as yet. There are some works being done, though, to make building security token services easier, and none of that is really available right now. So. In general, how does this relate to security within a client application? So the question is whether a service, should the service be the controller of security, or should you still be adding duplicate security verification within the client app? And I think what you're talking about here is doing, role-based security in the client UI as well to prevent the user from seeing features that they want to access when they're not inclined to do it. And I do discuss this with people quite a lot, and the idea of getting a set of claims not only to authenticate, using a token to the services, but actually to keep those claims at the client so that you can make the UI more intelligent about what you're allowed to do or not in this context. So I do talk to a lot of folks about that, and many folks are using the idea of the SAML token and that set of claims to also limit UI. It's not built in, so the only challenge there is that you have to write the code that will work with the claims in the UI. It's not that it's that difficult, it's just yet another thing to master. And another question, when you're using role-based security, what recommendations do I have about authorization between services and the database? So in general, I recommend Windows authentication to the database, and that you run your services in a separate process that has the rights to talk to the tables it should. And the user has no meaning down there. You might need a user for audit trail, and so you might pass a username just to have an audit trail of any access, and that's also very popular. But that becomes a parameter to the store procedure, as opposed to the actual authentication of access to a set of tables. Because if you use user credentials for that, then you can very quickly kill the system if you have thousands of users that need to be, provisioned and deprovisioned access to tables and so forth. It just has no meaning down there. And another question is it a must that each claim has the user credential token? And does the claim issuer depend on the language? Okay, so I'm not sure I understand the first part of this question. Each claim has a user credential token. Claims are completely customized. You decide what claims need to be. It could be a birth date, it could be a username, it could be an email address, it could be a right to create something or delete something, it could be a feature in the application, and so on. So, I'm not sure I understand that part. The second part of the question, does the claim issuer depend on the language used? No, not at all. In terms of the issuer, if you write the code in the custom authorization policy, as I showed you in the first part of this, then that is really, you are the issuer, right? Your code is the issuer. You could almost say the application is the issuer. So you just give it a friendly name in that case, because you've already verified that you trust the call, and you're already in your own custom authorization policy, so you decide what the issuer is yourself. When you're receiving a SAML token from another service, so token issuer, then they will usually use a certificate to sign the SAML token, for example, and you only allow in, as I showed you in the configuration, those trusted issuers. So it has nothing to do with language of programming. It has to do with standards-based implementation. I talked about ASP.NET. Another question. I talked about ASP.NET role-based security. Is that available to WCF without being hosted in IIS? Yeah, sure. You just have to configure the local SQL Server, connection string, and you still have to provide a section for the web config that enables roles and so forth. But you can use role-based security, certainly, in WCF using ASP.NET, absolutely. And that looks like it for the questions right now. If you have follow-up questions, feel free to email those to me. Another new question. Is there a great CardSpace book? You know what? You probably... there is a new CardSpace book out. I don't remember it off the top of my head, I'm afraid, so you might want to email me that question, and I'll look that up. Okay, so that looks like it for the questions. Feel free to email afterwards, and thanks again for attending today's webcast.
All right, and with that, I do want to extend a very special thank you to you, Michelle, for your presentation today and answering all the great questions we did have come through the queue. Well, ladies and gentlemen, this is going to conclude today's session. Thanks again for joining us. You may now disconnect from the audio portion of today's presentation.